Hello everyone, welcome back to complete lecture series on M3 subject. We have started lecture series on short trick method for finding the particular integral. Already I have explained all the short trick method in my previous lectures. So in my today's lecture, I'm going to take one of the very much important example from SPPU exam previous year question paper. That example consists all my previous short trick method. So we are going to apply all the short trick method in our today's example. Okay, so let's get down into today's lecture. I will explain to you all first of all how can we go through this example, and then we go for the complete solution. For similar videos guys, you may check in my playlist. Okay, so I have example here. Okay, so solve d square y by dx square. Let me write the example here. Solve d square y by dx square plus 2 times dy by dx plus y plus 2 times dy by dx plus y, which is equal to 2 cos x plus 3x, 2 cos x plus 3x, 2 cos x plus 3x plus 2 plus 3 e raised to x. Okay, now see that if you observe this example, it seems like our linear differential equation with a constant linear differential equation. It gives right hand side, which is a cos function, okay, trigonometric function, plus polynomial 3x plus 2, like a x variable function, plus exponential function. Okay, so we are going to apply all these short tricks here for finding the solution. Okay, so you will get this question in your SPPU question paper for 4 marks. Okay, so don't forget such questions guys. These are the easy question. Okay, yes, so first of all, finding the solution. Okay, so solve means you have to find out the complete solution. What do you need to find? Complete solution oblique general solution. Okay, we are going to add here complete solution oblique general solution here. Okay, yes, so general solution, we know that complementary function plus particular integral is a complete solution plus general solution. Okay, so first of all, we go for finding the complementary function. So it is way easier for finding the complementary function. We just have to convert our given linear differential equation into the form of auxiliary equation. Okay, so auxiliary equation, let me write auxiliary equation. Okay, what is the auxiliary equation here? So replace the value of a d square by capital D square. Okay, so we're going to d square plus 2d plus 1, which is equal to 0. This one is our given auxiliary equation. Okay, so let's go for finding this auxiliary equation. So we are going to write d square plus d plus 1, okay, which is equal to 0. The multiplication of two number, which is 1, and their addition, it is a 2. Okay, so I written this form, okay, which is a d plus 1 and a d plus 1. Okay, these are the two d plus 1 and d plus 1, which is equal to 0. Okay, there is the multiplication, we get the minus 1 and minus 1. These are real and equal roots for our given auxiliary equation. So we are going to write its complementary function as c1 plus c2x e to the power minus 1 into x. Okay, m1x. This one is our complementary function. Let's go for finding the particular integral. This one is our main challenging task here for finding the particular integral, as we have all the function combined here together. Okay, so we are going to work here for the particular integral. So we know that particular integral can be written as 1 upon f of d into phi of x. Okay, we are going to write particular integral as 1 upon f of d into phi of x. Okay, so what is the 1 upon f of d? F of d is a d square plus 2d plus 1. It is the f of d here. Okay, 1 upon d square plus 2d plus 1. This one is the f of d into phi of x is a entire term 2 cos x plus 3x plus 2. Okay, this is the entire polynomial considered at 1. Okay, 3 e raised to x. This one is our right hand side I written here. Okay, and now let's proceed this value with the 2 cos x plus 3x plus 2 plus 3a raised to x. Okay, yes, so I'm going to write it as a d square plus 2d plus 1. Okay, d square plus 2d plus 1, okay, multiplied by 2 cos x, okay, plus 1 upon d square plus 2d plus 1. We are going to solve all of these values separately. D square plus 2d plus 1, 3x plus 2, okay, plus 1 upon d square plus 2d plus 1, okay, into 3 raised to x. Okay, this is the method, guys, to expand our given particular integral. Okay, because this particular integral it is applicable here, also here, and also as well here. Okay, so we are going to apply everywhere similar. Okay, so it shows that cos ax plus b, we replace d square as a minus a square. That means we replace minus 1 as a d square. Okay, so how we going to write? 1 upon minus 1 plus 2d plus 1 into 2 cos x here. Okay, yes, this one is the expansion over here for this term. Okay, so I written directly. So how I have written, you can check in my previous videos. Okay, cos x means cos ax plus b. Compare this one is the cos x. Okay, cos x plus 0, that means the value for a, which is 1 here. You comparing this. Okay, so whenever we have d square, we replace as a minus a square. Okay, d square as a minus a square, a is 1, then minus a square is a minus 1 here. Okay, so I replace this term here. Okay, so whenever we have polynomial, we take that as the denominator as the numerator. So 1 minus 2d plus d square. Okay, d square plus 2d. Okay, take it numerator here, d square plus 2d. Okay, that goes to the complete power minus 1. Okay, yes, and which multiplied by 3x plus 2 and 3 raised to x. Okay, 3 raised to x. How can we solve this one? So here we are going to replace e raised to ax. It is 1 here. Okay, it is 1, so replace d as a 1 only. That means we replace the value of a d as the coefficient of ax here. Okay, so that means 1 upon 1 square plus 2 into 1 plus 1. Okay, so I'm going to write this one plus 1 upon 1 square plus 2 into 1 plus 2 into 1. Okay, let me write here in another line. Okay, 1 upon 1 square, that means d square. It is a, it is 1, that means 1 upon 1 square plus 2 multiplied by 1, okay, plus 1 into 3 raised to x. Okay, this one. Yes, go for solving next steps. So how we write? 1 upon minus 1 plus 1 get cancelled, 1 upon 2d. Okay, 1 upon 2 times d 2 cos x. Okay, 1 upon 2 times d 2 cos x, that 2 can be cancelled, plus 1 minus d square plus 2d raised to minus 1 into 3x plus 2. We have to go for the expansion. We have to expand this term by using 1 minus x raised to minus 1. Okay, 1 minus x raised to minus 1, that way that I explained in my previous lecture. Okay, so for right now, keep this term as it is. Okay, keep this term, entire this term as it is over here. Okay, as we are going to solve remaining term first. Okay, 1 upon 1 square plus 2 into 1, 2 into 1 2, 2 plus 1 3 plus 1 4. Okay, that means 3 divided by 4 e raised to x. Okay, this one is the last step. Okay, 1 upon 2, that 2 get cancelled with the 2. Okay, and derivative of 1 upon d into cos x, that means derivative of integration of a cos x. Okay, that means 1 upon d into f of x can be written as integration of f of x. Okay, this one is the standard form. Apply over here. Okay, so integration of cos x. What is the integration of a cos x, which is a sin x? Okay, okay, integration of cos x, which is the sin x, plus 3 by 4 e raised to x, plus, now we have to solve this term. Okay, so 1 minus x raised to minus 1, that means we write 1 plus x instead of x, replace the entire term, d square plus 2d. Okay, 1 plus x square, that means d square plus 2d bracket square plus so on, and into 3x plus 2. Okay, 3x plus 2, it is remaining term. Yes, so sin x, take it here, sin x plus 3 by 4 e raised to x plus, now 3x plus 2 multiply here, 3x plus 2 into 1, which is a 3x plus 2, okay, 3x plus 2 into d square plus 2d, okay. Yes, so we have to multiply here 3x plus 2 into d square plus 2d, okay, that we have to solve it further, plus d square plus 2d into 3x plus 2, okay, plus you have to multiply here as well up to so on terms, okay. Yes, this is way. So let's go for the next step. Sin x plus 3 by 4 e raised to x plus 3x plus 2 remains same, okay, plus d square 2 times derivative of a 3x plus 2. What is the first time derivative of a 3x plus 2, which is a 3, okay, and 2 times it goes to the 0, that means it gives this term 0, plus 2 times derivative of 3x plus 2, that means 2 times derivative of 3x plus 2, which is a 6 here, okay. So we left here with the term 6 only, that means this step gives here 0, plus this step 2 times derivative of 3x plus 2, that means 2 out here derivative of 3x plus 2, which is a 3, 2 3s are 6, and left over all the term it goes to 0, because these are the higher derivative, and higher derivative for this function always gives us the value 0, okay. Then next value can be written as sin x plus 3 by 4 e raised to x plus 3x plus 2 plus 6 8. This one is our required particular integral, okay. This one is the required particular integral. So you can add this particular integral with this complementary function, okay. This complementary function plus this particular integral gives us the required complete or general solution. Now see guys, these are the question from SPPU question paper, 4 marks questions, okay. Nothing it is difficult here, everything it is easier, okay. I hope you all have understood everything here in my today's lecture, okay. Even after, if you found anything difficult, let me know in my comment section, okay. I hope you all have understood everything here. So if you have similar example or anything difficult with you, let me know, or you can comment me in comment section. I will come up with the solution here in my YouTube channel. So I hope in my today's lecture those topic I taught here, you all have understood everything well, okay. So thank you everyone, thank you for my today's lecture.